Welcome to this YSL tutorial. In this video we're going to talk about for each loops in Excel VBA. So what we'll cover in this video are all the techniques you'll need to loop over collections of objects. We'll start with a description of the basic for each next statement and show you how you can use object variables to process that kind of a loop. Then we'll show you several examples, starting with looping over the worksheets collection, and then how to loop over workbooks, chart objects and cells. And hopefully what you'll get from that is how consistent the code is to loop over any collection of objects in VBA. We'll finish the video with a quick look at writing nested for each loops and give you a couple of examples of those. So let's get started. In VBA, a for each statement allows you to loop over all of the objects in a collection. To demonstrate the basics of how they work, we're going to start by looping over the worksheets collection and simply printing the name of each worksheet into the immediate window. So I've already started a simple subroutine and given it a sensible name. The first line of code we need to write in here is to declare a variable which can hold a reference to a single one of the objects that belong to the collection we're looping over. So we're looping over the worksheets collection, which means the individual objects in that collection are called worksheet objects. So I'm going to declare a variable called singlesheet as a worksheet. To begin looping, we write the words for each, and then we use the name of the variable that we've just declared, so in this case singlesheet, in, and then we state the name of the collection to which these objects belong. So the collection that a worksheet belongs to is simply called worksheets. There's quite a nice relationship in most cases in VBA. When you're looping over a collection of objects, the relationship between the type of object and the name of the collection is the singular and the plural of the same word. So you'll see that pattern repeated a little bit later on. Just to continue with this example though for now, to end my loop later on, or to go on to the next item in the collection, I'll need the next keyword, and I always prefer to say what next thing I'm going on to. So I'm going to use the name of my variable again. It's worthwhile mentioning that you don't need to put that in there, that you can just get away with writing the word next and that will work happily. But I always like to make mine a bit more obvious, so it describes what's going on in a bit more detail. All we need to do now is in between the for each and the next lines is we need to state what we want to happen to each object. And all I'm going to do is use the debug.print statement, debug.print, and I want to print out the name of the object that's stored in my variable at that point. So I'm going to reference my variable again, singlesheet dot name. It's worthwhile mentioning that you get the full IntelliSense list here of every property and method that belongs to a worksheet object. So it's the name property that we're interested in this case. And that's the code written. All we need to do now is execute it to see what happens. Before we start, I'm going to head to the View menu and make sure that I can see the immediate window by choosing that option from the list. And I've also made sure that at the bottom of the screen I can see my worksheet tabs, because there's another little thing that I'd like to point out while we're stepping through this routine. So if I click anywhere inside the subroutine and start by pressing the F8 key once, just wanted to reassure you that at this point the single sheet variable references nothing, so it's an empty object variable to begin with. As I begin stepping through, the first time that I execute this line, the for each statement, that's the first point at which VBA will set a reference to an object using this variable. So essentially what happens is VBA sets a reference to the first object in the collection that we've referenced here. So if I try to hover the mouse over the word single sheet now, I don't see anything. If I hover the mouse over a property of that object, however, like the name property, that gives me a clue as to which object that variable is currently referencing. So that shouldn't be any surprise that when I press F8 now, it prints the name sheet 1 into the bottom of the immediate window. And then I find the next single sheet statement. So when this line executes, what VBA will do is set the single sheet variable to reference the next object in the collection. In this case it's going to be sheet 2. One little thing to point out though, before I just execute this line, just watch what happens at the bottom of the screen. Sometimes people expect this to physically move on to the next worksheet, but if I press F8 now, you'll see that isn't the case. If I hover the mouse over singlesheet.name, you can see that we're referencing sheet 2 in the single sheet variable, but we haven't physically moved on to sheet 2 at all. That's not what this type of loop does, and some people get a little bit confused by that. It can lead to some weird little bugs when people assume that happens. So if I press F8 again, that's just going to print out the name of sheet 2 into the immediate window. Then next single sheet must be sheet 3, is the only one left. And there it is. I'll print it out. When I've run out of objects in the collection, and bear in mind that I could have 30 or 300 worksheets in this collection, when I've run out of objects, once I've processed every single one of them, the loop will exit automatically, and then we'll carry on with any other code in the subroutine. As there isn't any, we'll just end our sub. So there's the first basic example of looping over a collection of objects. For each loops can be useful for all kinds of different reasons. So for example, rather than just listing out our worksheet names, let's extend our subroutine so that it protects the worksheets as well. So you may be familiar with worksheet protection from working in Excel. You can, for instance, right-click on a worksheet name and choose Protect Sheet, or you can also use the Review tab in the ribbon and choose Protect Sheet, but it's something you must do on a one-by-one basis. You can't protect all of the worksheets in one go. So our loop is going to quickly protect each worksheet one at a time, far quicker than we could do it ourselves. Back to the VB editor, I'll change the name of my subroutine slightly, in fact completely. I'm going to call it Protect All Sheets. And we don't need to change anything about the loop itself. We still need a variable, which holds a single worksheet. We still need for each and next. All we need to do here is replace debug.print with a statement that does something useful. In this case, we want to apply the protect method to the single sheet object. So single sheet.protect. If I type in a space after the word protect, you'll see that I've got a bunch of optional arguments, one of which is password. I'm not going to provide a password here, I just want to perform this method. But if I did want a password, it'd be nice and simple. You just enter your password as a string. As I say, I'm not going to do that in this example. All I'm going to do, if I remove the immediate window, I'm going to run this subroutine quickly, run, and what I should find now is if I go back to any worksheet at all and try to change anything, I can't because it's protected. And that's true even though I haven't actually physically selected any of these other sheets, they're still protected. So there's another quick example of using a for each loop to process the worksheets collection. I suppose that I should have a subroutine which allows me to unprotect all my worksheets quickly as well. So rather than having to do that one by one, a quick easy way to do that is to copy and paste. It's not cheating. Change the name of the subroutine to unprotect all sheets, and then simply change the name of the method that we're applying to each single sheet. So single sheet.unprotect, unsurprisingly, and there we go. Obviously, again, if I'd added a password when I protected the sheets, I'd also need to provide a password when I unprotected them, and you'll see there's an optional parameter there that I can use to do that. However, I haven't added a password, so all I need to do here is run the subroutine, and now all the sheets are unprotected, and I can type stuff in again. Easy peasy. So, quick simple examples of looping over a collection of worksheets. So far, all of our examples have looped over the worksheets collection, but I want to show you how easy it is to adapt this code to make it loop over any collection of objects, so workbooks is the next example we'll do. I'm going to write another new subroutine. I'm going to pop that up at the top of my module. I'm going to call it sub, and again we'll just list out the workbook names to begin with. We'll need to begin the subroutine by declaring a variable, which can hold a single workbook. I'm going to give it a slightly more descriptive name as usual, so I'm going to call it single book as a workbook object. Then again, the loop begins with for each. I use the name of the variable, single book, and then I say in, and this time the collection name that a workbook belongs to is simply workbooks. So again, we're seeing that pattern where we've got the singular word as the object and the plural of the same word as the collection. Workbook, workbooks, worksheet, worksheets, and you'll see that pattern repeated again and again and again. We need to close the loop or move on to the next object. I'm going to say next single book, and then inside that loop I'm simply going to say again debug.print single book dot name. And again, I've only got one workbook in my collection at this point. If I redisplay the immediate window using the view menu and then clear out what's in there already, if I use the F8 key to begin stepping through, you'll see this loop effectively processes itself once, prints out the name of the workbook, and then ends. If I switch back into Excel briefly and create a few new workbooks by holding down the Control key and pressing N for new 2 or 3 times, switch back to the VB editor. What I can now do, if I clear out what's in there again in the immediate window, when I use the F8 key this time, in fact it might help if you could actually see how many workbooks were open there. You see these all belong to the workbooks collection now, so we'll see this loop processes more than once. It'll process 4 times, in fact, because there are 4 open workbooks in the workbooks collection. Now again, just printing out the names of all of our workbooks isn't particularly useful. So what we'll do is extend this subroutine to make it close down all of our workbooks, except for the one that our code is running in, so except for the top movies workbook. So I'm going to change the name of the subroutine to close all books, except this one. It's quite a long descriptive name. There we go, close all books except this one. We need exactly the same loop as we had previously, so we need a variable that holds a single workbook and then loop over each object in the appropriate collection. Rather than debug.printing the names of the objects though, what we're going to do instead is close down the workbook. So to do that, we can refer to our variable, single book, and then we can apply the close method to the object that that variable refers to. There are several optional parameters for the close method, one of which is whether or not we save changes. I'm not going to bother in this case. All of our workbooks, the workbooks I'm going to close down, haven't had any changes made to them, so I don't need to save anything about them. So, you may well be able to spot an obvious problem with this subroutine as it stands. If I try to process this loop, the very first workbook that exists in the Workbooks collection is the one in which my code is running. So what would happen immediately is that this code would try to close down the top movies workbook, and I don't want that to happen. So what I need to do is somehow exclude that workbook from being included inside this loop. You can't technically exclude it from being processed. What you can do is use an if statement inside the loop to prevent any actions happening with a particular object. So I'm going to use a basic if statement in here that's going to say if singlebook.name is not equal to. Now, one way that I could test for the name of the object is to actually use what I printed out here earlier, topmovies2012.xlsm. So if I open a set of double quotes, and then I could copy and paste that name into the statement, then add the word then to the end of the statement. So if that's true, then close down the workbook. Otherwise, well, don't do anything. So if it's not the top movies workbook, don't do anything to it at all. So that's one way to test for the name of the workbook, to exclude Top Movies 2012. One small problem with this is, what happens if I save this workbook later on with a different name? Then this code isn't going to do its intended job anymore. So a slightly more reliable way to do this is, rather than using the literal name of the workbook, we can reference the name property of the this workbook object. So you may remember from a previous video we've talked about the this workbook object. This workbook by default refers to the object, the workbook that your code is stored in. So if I say this workbook.name, then it doesn't matter what I've called my workbook later on, I can save it with any name at all later, and this code will still make sure that this one does not get closed down. So if I use the F8 key to begin stepping through, we'll see singlebook.name at this point is Top Movies 2012, so my variable is currently set to refer to the workbook that my code is stored in. That has exactly the same name as this workbook, so these two name properties give me exactly the same value. So that means that this if statement will exclude the Top Movies workbook. When I move on to the next workbook, that's book 2, which is not the same as Top Movies, so that will close that workbook down. We should have seen that happen actually up there in the immediate window, sorry, in the Project Explorer. In fact, we should have seen this happen for all of these. So those 3 workbooks now, finally, have been closed down, and you'll see they've all disappeared. And then we end the loop because we've run out of workbooks to process, and then end the subroutine. Sometimes when you're looping over a collection, you might want to state which object your collection belongs to. And one good example of where you might want to do that is when you want to loop over the collection of worksheets in another workbook. So I've already created another brand new blank workbook called Book 2, and what I'm going to do is start writing the code that will allow me to loop over its worksheets collection. So I'm going to say dim single sheet as a worksheet, as usual, and then I want to say for each single sheet in worksheets. Now that's the same statement that we've written a couple of times already in this video. What this statement actually does is it loops over the collection of worksheets in whichever workbook is currently active. And that might not be book 2, and in fact there's no code that I've written in this subroutine that makes sure that we're in the book 2 workbook. So instead of relying on that being the case, what we can say instead is, instead of just saying worksheets, we could say workbooks book2.worksheets. So that will make sure that when we process this loop, it will only loop over the worksheets collection in that specific workbook. Again, we can write the next single sheet line as usual, and what are we going to do? We're going to protect all of the worksheets in that collection. So we're going to say single sheet dot protect, just as previously, dot protect, and there we go. All right, so if just to prove that the sheets aren't protected at this point, if I just quickly switch back into Excel, and I'm on book 2 at this stage, and I can type things into these sheets happily, so there's no problem with doing that at this point. If I switch back to the top movies workbook, and then back to the Visual Basic Editor, just to prove that it does actually work from another workbook, if I just run the subroutine, and then switch back into Excel, and then switch back into into book 2, and now I'll find that I can't type anything into any sheet in that workbook. So that's the simple way that you can qualify your collection name with the containing object, in this case a workbook. In some cases, qualifying the name of a collection with its containing object is optional, so an alternative way to have written this subroutine would have been to simply say, before we started processing the loop, workbooks book 2.activate, and that would have made sure that we were in the correct place anyway, so we don't technically need to qualify this collection with the name of the object. But in other cases, it is compulsory to qualify the collection name with the containing object. And one great example of that is when you're processing a collection of chart objects, or in fact anything which sits on a worksheet. If I switch back into Excel quickly, what I'm going to do is head back to the top movies workbook, and I'm going to create 2 very simple chart objects that will sit inside this worksheet. So I'm going to make sure that I haven't got any cells selected, because what I want to do to begin with is insert a couple of blank charts. So I'm going to use the Insert tab in Excel 2010, and same in Excel 2007 or 13 as well. And then I'm going to insert one blank chart, just move it over here, then select another blank cell, insert, I'm going to insert a pie chart as well. So there we go, we've got 2 chart objects sitting on a worksheet. If I want to process this collection of objects, and I want to set their data source, so I want them to essentially, I want them to show the running time in minutes of our films. To process that loop, I need to do something quite specific. So let's get back to the Visual Basic Editor. And I'm going to write another new subroutine, which will set data for charts. And the first thing I need to do is declare a variable which can hold the relevant type of object. So I'm going to say dim, I'm going to call it single chart object as chart object. It's quite important that in this particular example, because the charts are embedded on a worksheet, don't use the word chart here. We're interested in something called a chart object. You'd use chart if you were looping over separate charts saved on different sheet tabs. Chart object is for the objects that are stored or embedded inside a worksheet. So there's the variable declaration. Then I'd want to say for each single chart object in, and technically I can write the word chart objects here. It doesn't appear in the IntelliSense list, which is a clue that something isn't going to be quite right. I could say next single chart object, and I'm not going to try to do anything inside the loop at this point. All I'm going to do is try to execute this code, and you'll see that it will fail immediately. So it doesn't recognise the word chart objects. Chart objects has to be qualified with the name of the worksheet, or a reference to the worksheet object, whose chart object you're trying to loop over. So in this case, all of my chart objects are stored in worksheets sheet 1, and I can reference that in a variety of different ways. The quickest and easiest by far, if I just reset my subroutine, the quickest and easiest by far is to use sheet 1.chartObjects. You'll see that chart objects is essentially a property of that worksheet object. So just to prove that this code will actually compile properly now, I can run it. It won't actually do anything yet, of course, but it will actually run without causing any errors. So what do I want to do in here? Well, what I want to do is to each single chart object, I want to set the source data for the chart that's stored inside it. So, slightly weirdly, a chart object is a container for a chart, and the chart object in there has a set source data method. This requires a reference to a range of cells, so I'm going to do this in as simple a way as possible. If I just quickly check, the range of cells I'm interested in setting is B2 to B15, and D2 to D15. Okay, so I can do that in one simple go. Back to the VB editor. I need to refer to range. Try that again. Range B2 to B15, comma D2 to D15. Do that in one single set of parentheses, and that essentially creates a union of those two ranges altogether. So now that I've done that, I should be able to, well, let's step through the code using the F8 key. So this will set the source data for the first chart. And if I switch back to Excel quickly, we should see that that's happened for one of the charts. There it is. Back to the VB editor, go down to the next single chart object, and this should do the same thing for the second chart. I'll just carry on stepping through to end the subroutine before I switch back into Excel. You can see that that's happened for both of the chart objects now. So there's one example where qualifying the collection name with the containing object is compulsory, and that's pretty much true for when you're looping over any collection of objects that are embedded inside a worksheet. One collection that you're likely to loop over frequently in Excel VBA is a collection of cells. And this is where our little relationship between the object name and the collection name, singular to plural, starts to break down. So whereas previously we've seen worksheet worksheets, workbook workbooks, chart object chart objects, with a collection of cells we can't do that. So let me show you what the collection of cells we're going to loop over for this example. Back in Excel, on my highest grossing films list, I've just tidied up a little bit. I've got rid of my chart objects. I've deleted a column of values that was there previously. The range of cells we're going to loop over is from cell A3 down to whichever cell is at the end of that list, however long the list happens to be. So to start making that work, back in the VB editor, I need to declare a variable which can hold a single cell as range. So range is the type of object I'm interested in. Now, previously what I would like to have done to follow the same conventions is to say for each single cell in ranges. But unfortunately that makes absolutely no sense to the VB editor whatsoever. What we need to use here is a reference to a block of cells that we want to loop over. So what we could do, instead of the word ranges, we could say for each single cell in range, and we could say for A3 to A15 in a nice simple way. And that would be perfectly acceptable. Later on I could say next single cell, and that would process each individual range in that block. But I said that I wanted this to work a little bit more flexibly, so I want it to process every cell from the top to the bottom. So I can say for each single cell in range A3, comma, and I can say range A2 dot end XL down, and that will make sure that it processes the entire list from top to bottom, providing there are no gaps in the list, of course. The thing that I don't really like about this particular example is that it makes the for each statement a little bit long and complex. Ideally, what I would do, and what I actually do in the real world, is take this part of the statement and store it in a separate variable, store a reference to it in a separate variable. So I'm going to declare a new variable called dim list of cells as range, and I'm going to set list of cells to be equal to this reference. So if I take this line, or part of this line, and move it up to this one, what I can then do is make the for each statement a lot more simple and elegant. I can say for each single cell in list of cells. All we need to do now is do something to those cells. To begin with, what I'd like to do is print out the name of the film to the immediate window if its length is longer than 120 minutes. So that means that I'm going to have to pick up on the values of the cells that are 1, 2, 3 columns to the right, and the value of the cell that's 1 column to the right. So to do that, back in the VB editor, I'm going to start with an if statement inside the loop. If single cell dot offset 0,3.value is greater than 120, then a couple of blank lines and fill in end if to make sure I don't forget. Then in the if statement, all I'm going to do is say if that statement has been true, then debug.print single cell dot offset 0,1.value. So if I display the immediate window again, view immediate window, make sure it's cleared out, and then start stepping through the routine, I'm just going to change the screen width so you can see the cells in the background. Again, just something that was kind of related to when we processed our list of worksheets. We saw that we didn't actually physically select the worksheets. When you process a collection of cells, you don't physically select those cells either. As I begin using the F8 key to start stepping through, I store the list of cells in that variable, and then I process them by looping over them checking if the value is more than 120. So for this first film, that was true. The value of the runtime was 143 minutes, so I get the first film printed out. You can see that it's that cell there, and then again the next film is 165 minutes, so we'll see that one printed out, and so on and so on and so on. Eventually we'll reach a film which is not more than 120. Here's one. So this film is only 116 minutes long, and that film is the Twilight Saga. Oh, thank goodness I'm not printing that one out. So I don't print out that film, and then I'm just going to press F5 to get to the end of the list a little bit more quickly. So you can see one quite interesting thing again. We're not physically selecting these cells. This loop is processed purely in memory. You don't actually physically see anything happening. Now, one interesting consequence of not having to physically select cells in this type of loop is it means we don't need to be anywhere near this worksheet for this loop to process. Once we've originally stored the list of cells from the correct worksheet, then this loop can carry on wherever else we happen to be. So what I'm going to do, I'm just going to resize the screen with again so we can see a little bit more of the code. And what we're going to do is, rather than list the film names into the immediate window, we're going to create a brand new workbook that will list out our films. So making sure that we've gone to the correct worksheet in the correct workbook, I'm going to first of all add a couple of lines that says this workbook.activate, and then sheet1.activate to make sure we get our list of cells from the correct place. And then once we've stored our list of cells, we can simply add a brand new workbook using workbooks.add. This will create a brand new workbook with 3 blank worksheets. We'll be on sheet 1 and range A1 in that workbook. So I'm going to say range A1.value equals list of long films, just to give it a quick title. And then I'm going to say range A2.select. So that puts us in the correct starting point. So at this stage, we'll be in a completely different workbook. But this loop will still happen automatically because our list of cells has been stored in memory way back at this point. So instead of debug.printing the name of the film, what I'm going to do is change the value of the active cell. So I'm going to change debug.print to activecell.value equals single cell.offset 0,1.value. And then on the next line, I'm going to make sure that in my new workbook, I move down to the next cell. Oops, that was a bit of a mistake, wasn't it? I'm going to move down to the next cell. So I'm going to say activecell.offset 1,0.select. Okay, so there we go. So again, I'd like to watch this happening in the background. So I'm going to change the width of my screen again. I'm going to use the F8 key to begin stepping through. So I've gone to the correct workbook, this workbook, and then gone to the correct sheet, sheet 1, then I'm storing this list of cells. Now I'm adding a brand new workbook, which in this case is book 3. I'm setting the value cell A1, moving to cell A2, and now I'm going to start processing through my list of cells. Not that I can actually see them. All this happens, it's very sort of abstract watching this sort of thing, because you have no concept, unless you could go back and see what those cells were, you have no idea what values are stored in them. Obviously when you're stepping through, you've got the ability to use the mouse hover trick, but it's slightly disconcerting seeing this sort of loop process when you can't see the cells that you're looping over. Eventually we get to the end, and there it is, the end of our loop. So for the final part of this video, I wanted to quickly talk about how you can write nested for each loops. So I've gone back to the simple routine we had earlier on, which loops over our collection of worksheets and protects each single sheet in that collection. Now what if you want to do that, not just for the collection of worksheets in this workbook, but for all of the open workbooks? So what we could do is simply wrap a loop of workbooks around the loop of worksheets. So we need another variable. I'm going to call it dim single book as a workbook, and then above for each single sheet I'm going to say for each single book in workbooks. I need to close that loop after where it says next single sheet, so I say next single book, and then just to tidy up, because I can't leave it as it is, I'm going to indent those 3 lines inside to get this lovely triangular structure to your code. One more little tweak that we have to make as well. When we say for each single sheet in worksheets, remember from earlier on that this will loop over the worksheets collection in whichever workbook is currently active. I don't want to have to activate each workbook, so what I'm going to do is I'm going to qualify the collection name with the containing object, and in this case it will be single book. So single book, I'll get it right in a moment, dot worksheets. So the outer loop will loop over the workbooks collection, and for each individual workbook we will loop over the worksheets collection in that workbook. And that will protect each single sheet for however many workbooks I've got open. So let me just quickly go into Excel and create, let's just create 2 extra new workbooks. So they are pressing Ctrl and N to create two new quick workbooks. I've got book 4, book 5 and top movies. So as I begin stepping through using the F8 key, this is going to loop 3 times for the top movies workbook. There they are. Those are all protected now. If I switch back to top movies and try to change anything, those are protected already. So back to the VB editor. When I hit F8 now, it's going to go to the next single book loop. So it returns to the outer loop and moves on to the next workbook, which in this case will be book 4. So at this point, book 4, I can change things. Back to the loop. If I process this loop, this will happen 3 times as well, because there are 3 worksheets in that workbook. Then it will process the outer loop again, so it returns the outer loop. Just to show you now in book 4, these cells are protected. So finally, we've got book 5 to do, and again this loop will be processed 3 times, so the inner loop goes 3 times, because there are 3 worksheets in that collection. And then it jumps out of that loop, jumps out of the outer loop, and carries on with any other instructions. So there's the basics of nested for each loops. And we could extend this even further. What if we didn't want to do something to a collection of worksheets? What if we wanted to loop over a collection of cells or a collection of charts in each sheet in each book? You get the idea. You can just carry on nesting these loops to perform hundreds of thousands, millions of operations with some very, very simple code. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.